04 and 228. And the emphasis is on Fortran programming. Today we are going to look at the foundation of Fortran character set 04 and 22. And that will be the focus of the lectures we are going to have today. I thank you for listening, and I can assure you it's going to be a very nice time. Because we do know that some of our very dear students will miss this class, we are streaming it live so that you can have a glimpse of it after this time out. No. Yes. Now we are going to look at the Fortran character set. But we'll be taking it from the basis. And when we say we're taking it from the basis, it means that we are going to look at the foundation of Fortran programming. As you do know that a recording has been activated and attendance is also activated. When we talk about character sets, what are we talking about? We are talking about those characters, those alphanumeric characters, those arithmetic symbols, and many other symbols that are valid as Fortran symbols usable within the Fortran programming framework. So we have a lot of them that are valid. However, for ease of understanding, we have categorized them into 3, and every other one we take after the 3. I will take it from the Fortran 90 and Fortran 95 program, because this is the programming language to which the object-oriented Fortran, which we do right in the current time, are based upon. The difference, as I've earlier told you, is that the object-oriented Fortran has additional object identifiers in it, and it obeys the OOP concepts of abstraction, inheritance, polymorphisms, such that programming a set of ideas becomes so easy. The character set that allowed in Fortran includes the following alphanumeric. And I want you to have a grasp of this alphanumeric character. When you say alphanumeric, we are saying alphabet and numbers. So it can be alphabet and numbers, it can be alphabet combined with numbers using the underscore. Underscore is like minus. In most computers, Windows-based computers, you press Control minus, it gives you an underscore in your text editor. So, ladies and gentlemen, alphanumeric are all characters between A to Z. So it can be A, B, C, D, E, F to Z. Of course, the A to Z can be in lower cases, and the A to Z can also be in upper cases. So it means that if peradventure you are asked that is this acceptable in Fortran, and you have a lowercase w, it is correct, it's an acceptable character in Fortran. If you also have an uppercase k, it is also acceptable in Fortran. Again, you can also have 0 to 9. And I mentioned this in the last class that when you count digits, you don't say from 1 to 10, you say 0 to 9. And all of these can be combined together with an underscore. So I can have a small letter A, a capital letter B, and the number 7, and the number 8, and a small letter W underscore a small letter K. All of them can form a string within the Fortran program. Fortran also allows for arithmetic symbols. The arithmetic symbols includes the addition sign, which is generally known as plus, the subtraction sign, which is generally known as minus, the multiplication sign, which is generally known as asterisk, the division sign denoted by slash, and the powered sign, which is double asterisk. So if I write 2 plus 2, you know I am telling the computer to add 2 to 2, and the expected answer will be an assignment into 4. If I say 2 minus 2, I am telling the computer to subtract 2 from 2, and the expected answer will be 0. If I say 2 asterisk 2, I am telling the computer to multiply 2 by 2, and the expected answer will be 4. If I say 2 slash 2 within a programming framework in Fortran, it will divide 2 by 2 and gives me an expected answer of 1. If I say 2 asterisk asterisk 2, it will be equals to 2 raised to power 2, which will be 4 as expected. So we have other miscellaneous symbols that are used. They include the comma, the decimal point, the less than, the greater than, the equal to, and all of them are allowed and permissible within the programming framework in Fortran. But what is important is for us to understand the structure of a Fortran statement. Once we have a grasp of this structure of the Fortran statement, we will be able to identify a valid Fortran statement at any time. Once we are able to identify a valid Fortran statement, it also means that we will be able to conclude that some Fortran statements are not correct. Let us look at the structure. But when you talk of a structure, what are we talking about? We are talking about the architectural design. For example, you want to build a house. The first thing that comes to your mind is, let me have an architect to draw up my conceived building. So you want to look about the architectural design is going to be based on the structure. The structure is the implementation of that design. So you want to have a foundation that has 2 toilets of each flat getting close to each other, backing each other, 2 living rooms of each flat backing each other. You are going to have a structure on ground as foundation into which you build up other blocks in the building. So when you talk about the structure of a Fortran statement, we are talking about how it is written, how the steps to be taken. If you talk about the structure of a class, the structure of a class will generally be that the lecturer will be conducting a class by teaching the students or lecturing the student, as the case may be. The student will be listening, asking questions, and taking notes as appropriate. So today we are looking at the structure. Today we are looking at the structure. I'm sure you can hear me because I think my microphone is active. Someone said I can't hear you, but I think my microphone is on. So you should be able to hear me. Today we are looking at the structure. But what do you call a statement? When you have a program in any language, each line that makes up a sentence in that program is called a statement. Each line that makes up the sentence in that program is called a statement. So a program consists of a series of statements. So when you, in English language, when you talk about, and I have always told you, in the computer paradigm, in the computer world, so to say, when you talk about a terminology, that terminology will most times have a reflection to the general knowledge of that word. Because computing, computer science, computer technology, and all associated subject areas came after a lot of these subject areas, a lot of other subject areas, a lot of many of those terminologies have been existing. So when you say a statement, you know, between you and I, we can now say, stand up and make a statement. I want to make a statement. It means that you want to start something in terms of words and complete that word, those set of words, by passing a message, having a meaning. And that's why you say a sentence. A sentence is not a phrase, it's not a clause. It is a complete set of words that has a meaning. So a sentence, so to say, in a programming language is called a statement. So a program consists of series of statements. So each of those statements are designed to accomplish a task. There must be a goal. There must be a reason. There must be a purpose. There must be a purpose for that sentence. I want to advise that you do not distract this class with your chat, please. Your chat messages should not distract listeners of this class, please. It should not be used as a means of distracting those that are listening. This is a very serious class, and I thank you for listening. And I'm sure you will not distract us again. Thank you. So, I'm back. So we now say that for each statement in Fortran, we are trying to accomplish a task. There is a goal, there's a purpose, it's driving a message, it's passing an instruction to the compiler. It is telling the compiler, go and do this. And you will see situations where the compiler will have to ignore such messages. But of course, when you say a statement, now that we all understand what statements are, the next thing is to say, what are the types of statements? There are two basic types of statements. One are statements that are going to execute a task that we speak to the compiler, and those ones are called the executable statements. These are statements that describe the action taken by the program. 2 plus 2, 2 minus 2, the actions taken. 2 times 3 is a statement. It tells you that it must be executed to get a result. But there are other sets of statements that are called non-executable statements. These are statements that are used to provide information that are necessary for the proper operation of the program. Not even only the program, they are even necessary for proper understanding of the program. So if peradventure, you need to drop your programs, your set of codes to another developer, you will now have non-executable statements that can guide the new developer as to reasons why you have added some executable statements within the programming codes. But there are rules that govern all of this. But before we consider the rules, one very important concept to note is that when you are talking about executable and non-executable statements, you must be conscious that they are both used within the programming framework. But the rules of Fortran statements includes that each line may be up to 132 characters long. Each line may be up to 132 characters long. If a statement is too long to fit into a single line, it may be continued in the next line. But what do? You put an ampersand at the end of the first line. So you can have a statement is not defined. If you look at what I said earlier, I mentioned clearly that when you are talking about statements, which generically you can use the concept of a sentence to interpret yourself, we are talking about a set of instructions that are meant to pass a message. The message might be an executable message, it might be a non-executable message. However, they are meant to pass a message. Ladies and gentlemen, interestingly, a sentence, even in English language, is not defined by the number of words. The boy is good. The boy is good is a four-worded sentence. And you have sentences. When I was going, I saw him and he came and he called me and he greeted me. That is also a sentence. So a sentence or a statement in the Fortran programming is not defined by the number of characters that makes up that particular sentence. But what we are saying is that a line, so do not mix it up. We have not told you that a sentence, a statement is 132 character long. What we have said is that a line can take up to 132 character long. But all of this concept came in the days of programming with what we call a coding sheet. A coding sheet is what is now being implemented in environments. They have your programming environment, your Plato, your several developing environments that you can now log into the environment and do your real-time programming. Then, when all of these programming needs were coming up, developers relied on what we call the coding sheet. The coding sheet will allow for Fortran programming 132 characters. However, this is for each line. But if you have a statement that goes beyond the same line, all you have to do is to add an ampersand to the current line, then you can continue the statement. So when the compiler is reading, the statement, when it sees an ampersand at the end of that current line, it takes it that, okay, I still have some other lines to read until it gets to the end. For example, if you now want to say output equals to input plus input 1 plus input 2. And what you see here, this sign, this apostrophe sign, is to tell us that every other thing after it is not to be executed by the compiler. It is just providing information about what is on the left-hand side. So this is to tell us that this statement is sum of inputs. So look at the sum of inputs as is written. It will add the input 1 and input 2 and give us an output. If you also look at the second line, you will find out that it will add input 1 ampersand input 2. The ampersand tells the compiler that there is still a statement. The statement continues in the next line. Then do not execute until you get to the next line. And after getting to the next line, then if you do not say an ampersand and say a full stop, then you can execute it, send the statement to the compiler, get a result, and put the result as output. So the two statements above are equivalent. The one with the ampersand and the one without the ampersand are all equivalent. But I told you something very interesting, that anything you have after the exclamation point, we also call the exclamation mark, is called a comment. Commenting a code is very, very important. It tells other users and even yourself. Imagine yourself developing about 10, 20, 25, 30 softwares using Fortran programming. You find out that at the time you want to visit one of the earlier programs you have written, you want to remember why you have used some set of commands. The only thing that can aid your retention, your understanding of what you have written, is by checking out the comments that are included in the lines of code. So comments are very essential. And I think it is one of those areas that has guided the development, that has seriously guided the development of software in current time, because it has helped us in the concept of what we call the open source. Open source codes are available. They are codes that have been developed by a user and found it very, very useful, and they have put it in a public domain that you can use it in a creatively common way, and you just give credit to the source. But when you build on an open source and you get a new product, the rules of ethics of engagement requires you to also donate. We use the word donate. Donate that same code to a repository. If not that repository, to another repository, and you make reference to the repository. A repository is where you have a collection of all of your source codes. To that repository, that this is where I have taken the source code. So one can use labels in some statements. A label can be any number between 1 and 999,999. A label usually comes to the left of the statement. A label is like numbering the lines of code. Statement labels are not generally common in modern Fortran, not even in modern Fortran. In many Fortran programming languages, you will not see labels. Labels are no more common because labels was used initially in the days of the coding sheet, so that if you want to troubleshoot and you want to identify where you have a problem within your code, you can quickly use your label. Now, we have now gone into the basic structure of the program of the Fortran statements. But let us look at the structure of the Fortran program. The program itself, let's look at the structure. In Fortran, a program can be divided into 3 sections. Within the same program, there are 3 sections. It's just as if you are getting into a house and they tell you that this house is a 3-bedroom flat. So what it means is that in this house, there are 3 bedrooms. So the bedrooms are a set of sections. The sitting room is also a section. The toiletries, the reception, whatever you have is also a section. So within the same programming language, within the same program codes, within the same distribution, you have 3 sections. The first section is called the declaration section. The second section is called the execution section. And the third section is called the termination section. All of these are together in the same program. So if I want to write a program that will count the number of students in this class and give each one of them $100, but we remove $15 for anybody that have not attended the last class, that program will contain declarations, will contain execution, and will contain termination. If you look at my slide very, very carefully, you will see that I have used the word declarations. I did not use declaration because you are going to declare as many declarables as possible. As many variables are needed to be declared will be declared. So, but all of the things you are declaring here are non-executable statements. They are not hitting the compiler to say, do this. They are not executable. They are just providing the compiler a definitive format of the content of that code. They are just telling the compiler that, yes, in this program today, X is an integer. They are telling the program that in this code today, in this set of codes that we are submitting today, y is a real value. Y is a complex number. Y equals to a plus bi, which makes it so complex. Q is irrational. So it is going to declare. So because you have a lot of variables that will be used within a programming framework, we use the word declaration. So you are not going to declare just one thing. You are going to declare everything that makes your computational process necessary. And I want you to always remember this. I have said it in earlier versions of these classes, that you do not have to write a program for a simple problem. Ladies and gentlemen, your program is written because you have a problem that is bigger than what you can solve immediately. I gave a scenario in this class. I am sure in 3 minutes, nobody can tell me the last value for somebody, for one of the members of the class. I just said that all you have to do is generate a set of fee and give $100 to everybody present in this class. Then deduct 15% of that $100 for those that did not come in the last class. And if you did not come to the class before the last, deduct another $15. These are not calculations that can explicitly be done on the go by your pen and paper. So you need the aid of a computer, and you need a reliable language. Language is the code, is the set of things you say that passes understanding between a man and another man. Now the language you are using is to just pass a message between what you are writing, the program, the problems you have, and the solutions you want. That language in translating the problem to solution is the programming language. But the programming language of emphasis in this course today is Fortran. So we say each of these, we say for each of the program you are writing, you have to contend with 3 basic structures within the program. The sections are the declaration sections. The sections are the declaration section. Excuse me. Yeah. The sections are the declaration sections, the execution section, and the termination section. I have successfully broken down the declaration section, and I'm sure we do understand what you're talking about. Now we come to the one that is important. This is where you have actions. Where you have actions that act on events that create a report called result, which is technically referred to as an output. Execution section. This section consists of one or more statements describing the actions to be performed by the program. Simple. And that's why I tell you that this is where you have actions to be performed. So 2 times 2 is an action. This is where you see the actions that generate an output. Now we go to the last line, which is termination. Termination brings all you have completed to an end. You have started your program with a declaration. You are now ending it. It now tells you that this consists of statement or statements telling the computer end the program and stop running. End that program and stop running. So as part of the concluding framework for this class, we quickly look at an example. And you see that in this example, in which we have in this figure 2.1, the program is to read 2 numbers as inputs, multiply them, and print out the results. That's a program. So you can have a set of 2 numbers. You can have 1,002 numbers. That is, you have 1,000 numbers in A, 1,000 numbers in B. So what you are doing is that you are reading in A, you are reading in B, you are multiplying them, and you are giving us an output for each of A and B. The first thing in Fortran programming is that there must be a name for the program. There must be a name. But this is at your leisure. You can call it any name. You can name it anything. Today, our first program is going to be called My First Program. So the name of the program is Program My First Program. Then you can add comments. So you find out that the second line, the third line, the fourth line, and the fifth lines are comments. But look at it. We've done the comments in a way that it can tell you a whole lot of stories. The first line, the first comment says purpose. The second says the purpose is to illustrate some of the basic features of a Fortran program. And you saw that we can even comment and do not make any statement in that line. And the fourth comment says that declare the variable used in this program. So the next line is a declaration line. Now, those four comments are the non-executable statements that we referred to earlier. They are not going to be executed. Now we are saying that we want to declare, and like I mentioned to you earlier, that our declaration is saying that we have values, we have variables I, J, and K. I can remember that earlier in the classes we had before now, we have told you what variables are. We told you what integers are as well. So we have integer I, J, and K. And we say all variables that are going to be used in this program are all integers. So it means that the compiler is just going to read, this computer is just going to read that I, J, K have been given to me to use to add two values, to multiply two values and print out a result in a way that I, J, and K are all integers, whole numbers. So we go down to the next line and we say, get two values to store in variables I and J. That is a comment. So I have told you earlier, imagine, just as I'm making these classes to you, imagine that I'm sure you have all seen an Excel sheet. Imagine that in this Excel sheet, you have a column A, where you write, you remember when you want to fill your attendance in papers in classes in those days before we become very digitalized, you write A, name, serial number, 1, 2, 3, 4, 5. Imagine that. So when you have serial number, imagine you have A. Just imagine that in your head. And where you have your name, imagine you have B. Where you say surname, imagine you have B. So you have column A, your column B. Where you write 1, 2, 3, 4, 5, 6 to whatever, just imagine you have 20, 30, 40, 50, 60. Where you have your surname, imagine you have 100, 120, 130, 140. Just imagine that way. Now our program is to say, let us get values that will store in I. So that serial number that we call A, let us change it to I. If we change it to I, it means that all the numbers 20, 30, 40, 50 are values that we are storing in I. That is why we say variables. We contain values that can change in nature. So let us, that side that we have surname that we called B earlier, let us change it to J. So we can now have 100, 120, 130 as those variables and those values that are stored into J. So we have the values that are stored into variable J. We have other set of values that are stored into variable I. So our task is to multiply the variables I and variables J to get an output K. So we write, which is the command. This is the command to the compiler that writes. You open a bracket, you open a bracket, asterisk, comma, asterisk. This is the structure. Then you say enter the numbers to multiply. Then you say read. When you have your read, it reads out what you have written. So the K will now be I asterisk J because you have written into memory. So if you see this line here that has right, you have written this number to multiply the content of I and J. The content of I and J has been written into memory here. Then you are reading it out. So when you are reading it out here, you are telling the compiler to bring out those values that are here, and in a way that you have made a functional command to say for every I that is existing, asterisk J, put the value into K. And say write out the result. Write is like output. Output the result. Show us the result. That is right. When you write, when you read, what do? You read in. When you write, when you have an exam now, what you do is that you read it, you assimilate. Then when you are writing, you write it out. So reading is inputting, writing is outputting. So you are reading, you are writing. So what we are doing here is that we are now writing the result of what we read. And now we are writing the result of what we read and putting the result in K, which is also a variable. Then we say finish up. Finish up here is not a command in Fortran. And that's why there's a statement there that says that this is a non-executable statement called comment. Then we say stop. And after stop, we say end program, my first program. I'm happy that you have today, you have written your first program in Fortran. We'll be building on this knowledge to build up a higher understanding. The next class we begin. Okay, let us quickly, before we end it up, let's discuss that program. So once we discuss the program, we go to each of those stages. We look at the declaration statement in it. We look at the execution statements in it. We also look at the termination statement contained in it. So let's discuss it. The first statement of this program begins with the word program. This word is non-executable statement. But like I told you, I have discussed it earlier, but let us refresh it. It's just to give you the name of the program, that this is the name the program we send to the Fortran compiler. But in Fortran, a name must not be more than 31 character long. You must not have a name more than 31 character. And it can be a combination of alphabet characters, digits, and underscore as contained in our alphanumeric. I told you earlier that this class is being streamed live. So if you have any reasons to check it out again, you can visit the YouTube page, and you don't need to subscribe or do anything. The YouTube page is open for knowledge. So with or without subscribers, you will be able to learn. Just visit the place and do revisions they are in. So the name may be up to 31 characters long and may be a combination of any alphabet character, digits, and underscore. So if you are in a paraventure, you are asked an exam that if you have a combination of all of these set of characters, what is it called? We are talking about the alphanumeric character. But importantly, these are rules. These are rules. The first character must be a letter. The first character must be a letter. So you cannot start the name with a number. The first character must be a letter. The program statements must be the first line of the program. That is the name. Anyway, if you want to do something, what is normal is that you tell them the name. You have visited a new venue, and you want attention of the compiler. The right thing to do is to tell the compiler your name, so that the compiler can immediately place all the codes under your name. Somebody asked for a YouTube link, the link to the YouTube broadcast. And I'm so happy that one of our very, very smart students contained herein have actually made it available. So at any time, you can revisit it over and over again. So the first character must be a letter. The program statement must be the first line of every program. So being said, we look at the declaration section. This section begins with a comment stating that the variable declarations are to follow. The declaration begins with the data type integer. And I'm happy you remember that we have touched on all of this. followed by 2 columns, and then the variable name. Always put in mind that at this point, we are discussing the structure of the Fortran program using relevant example. So the declaration, we have the data type. For example, it can be real. I told you it can be a real value, it can be integer, it can be complex, it can be anything, any data type. Then it's going to be followed by the 2 columns, which you call double column, and also a variable name. A comment follows the variable name. Every variable name must be commented so that you will not confuse the compiler. So that you will not confuse the compiler. But like we said earlier, at the time we were defining this concept, that declaration section are non-executable statements. So now we come to the executable section. The first statement in this section is the write statement that tells the user to enter the inputs. It tells the user to enter the inputs. Then the second, we read the input and assign values, the I and J, to the corresponding variables. We have explained this. Then the third statement multiplies the 2 variables and the product of the product and assign them to a third variable called K. So it reads I and J and assign the product of I and J to K. The last executable statement is to print out the product in a screen. Ladies and gentlemen, we told you that there are 3 sections contained in a program: the declaration, the execution, and now the termination. If you look at the program we had, we say stop. The stop tells the computer to stop running the program. Do not take any action again. Do not execute anything again. So when the compiler, the compiler reads each statement, bam, bam, bam. Once it gets to where it says stop, it just stops. So it's not going to read anything further. After stopping the operation, the next thing is to end program. However, the stop command is optional. However, but the end program statement informs the compiler that no more statement exists. So even if you are not using the stop command, which is a convention for usage, the end program command must be used to tell the compiler that no more statement exists. Ladies and gentlemen, let it be of interest to you to know that all of these commands that are used in Fortran are used in a way to pass a message directly to the compiler. Because these are the commands that the compiler understands: read, write, stop, end. Those are the things it understands. Then it understands the executable commands. 2 times 2, 2 plus 2, 2 divided by 2, 2 raised power 2, the arithmetic commands. It understands that when you say you have an integer, you are talking about a real number. Your program will return an error if you have a wrong declaration as against what you have declared. If you declare a value and you say it is an integer and you write 2.0, the compiler will translate that 2.0 into a whole number and add on that 2.0 as if it's a whole number, because you have actually identified that what you are working on is a whole number. We quickly, before we leave, we quickly look at compiling and executing a Fortran program. Before a program can run, yeah, let's start it. Yeah, so we are talking about compiling and executing a Fortran program. But a program, before a program can be executed, it must be compiled into an executable program. In this process, what we do is that the code that you have written are linked to those libraries contained in the system. Now we quickly look at how this is done. We look at constants and variables. A constant is a data object. A constant is a data object defined before a program is executed. The interesting thing is that that thing you have been told long ago, years ago, about that thing you have been told long ago about a constant that does not change its value is correct. It's still valid in Fortran because it does not and cannot change during the execution of the program. Constants are used in developing very, very appropriate programs, essentially in maths problem. I do understand that you will always remember the pi, the constant pi contained in the area of a cycle. A variable, in contrast, is that same data object that can change the value during the execution of a program. So if you look at the sample we gave above, you remember that I told you I contains 10, 20, 30, 40, 50. That is a variable. It can take in many, many values, many different values. So it can change in the course of the program. So as the program is running, it runs the first line is 10 times 20, second line is 40 times 50, third line is 50 times 60, it's changing. But if it's a constant, you will see that 2 raised to pi r squared. That pi is constant. That pi will not change in the course of the program. Each variable or constant must have a unique name inside the program. Like we said, that the name may be up to 21 characters and can be a combination of alphanumeric figures, values, characters. We have explained to you that the first character must be an alphabet, and the name we assign a variable or a constant should be meaningful for the purpose. So if you are writing a program about the performance of students in CSE 104, you cannot put Don Jazzy there, program Don Jazzy. No, you have to put program CSE 104 or program that reflects the name. Ladies and gentlemen, that's been a very interesting session with you. And at this time, we'll be ending our interaction for the week. We'll be welcoming questions, comments on the chat, so that I can allow you to go and reflect on what you have learned. And we take up the same scenario in a week's time. I thank you very much for listening, and I am happy to accommodate your questions at this time.